Hi, dear student. How are you? Welcome back to another sessions of odd-even integration property. I'm Azad Ahmed Khan, your JE Mathematics mentor. So today's session we will discuss a statement of the odd-even property. Second, we will discuss the proof of the property, and third, we will apply this odd-even property to solve some definite integrations problem, which is very easy to manage and solve to these kinds of problem with the help of odd even property. So let's start. Okay, so as you mentioned, we will discuss first the statement of the property. The statement of the property is, suppose there is a function y is equal to fx, okay, and this function is continuous in interval of minus a to a, okay. Then the integration from minus a to a f of x dx is equal to 0 when the function fx is symmetric about origin. Symmetric about origin means its function when the function is a odd function. Okay, so this is the first part of this property. Similarly, integration of minus a to a f of dx is equal to 2 times 0 to a f of x dx when f minus x is equal to f of x, means when the function is symmetric about y-axis, means the function is a even function. Okay, so this is the statement of the property. We can summarize the statement of property here like this. The function if any function odd function integrate from minus a to a, the result will be 0 when the function is odd, and the result will be the 2 times of integrations 0 to a f of dx when the function is even. So this is the statement of the property. Let's move about the second part of this session, is the proof of the property. So, as you know, proof of the any property is very important to understand, to build the understanding of concept and build your knowledge. So, let's start the proof of this property. Let's consider this part, minus a to a f of a x dx. Let's break this limit of integrations from minus a to 0 f of x dx plus 0 to a f of dx. You know, there is one famous property in definite integration from limit. If there is a continuous function in interval a to b, then you can break the limit of integration from a to c f of dx plus c to b f of dx, where c is lie between a to b. Okay, so we recall this property in order to simplify and proof of this odd even property. Okay, so we can do one thing. Let's simplify this one by using by method of substitution. Let's just replace x in this integrations, just replace x by minus x. Then what will we get? This limit will be converted into a, and this will be 0, and this part will be minus x and dx, and we will get minus 1 out of this. Why? Because dx is equal to minus dx. Okay, and the second part of this property is, let's write as it is, 0 to a f of x dx. Okay, now let's write in a separate place, and that is just switch the minus a, this is the minus a of outside the minus a to 0, and we can write 0 to a f of minus x dx plus 0 to a f of x dx. Why? because there is a one more property in definite integral. If limit is a to b f of dx, then it will be equal to the minus time the order of limit of integration is reverse. It will be right, can be written like this. Okay, so I will call this one, and we can write all the property this term as this sum of two from 0 to a f of minus x dx plus 0 to a f of x dx. Okay, now let's apply the concept of odd even for function. If function f of minus f is equal to minus fx, it's mean if the function is a odd function, then it varies with you can replace minus fx, minus f of minus x is equal to minus fx, then substitute the value of this one on this integration. So it will be 0 to a f of x minus x plus 0 to a f of x minus n. Can you observe one thing? A whole this part and this part both are equal with negative sign. So this and this will cancel out, the result will be 0. So we have proof it. If the function is continuous minus in interval minus a to a, and the function is an odd function, then the result of this one will be 0. Let's prove second one. Second one will be odd. Again we will substitute this one in this result. The conditions of even function is minus fx is equal to fx. So let's substitute this result in this one, then it will be equal to 0 to a f of x dx plus 0 to a f of x dx. This and this both are same, then we can simply add 2 times 0 to a f of x dx. Great, we have solved it. Now the second part we have proved it. The minus, if the any function the define interval minus a to a, then limit and integration from minus a to f is 2 times 0 to a f of x. When the function is even, this is very important conditions. When the function is odd, it will become 0, and the function is odd even, this to 2 times of 0 to a. Okay, so let's take an example how we can apply this odd even property to solve a numerical problem. Okay, so let's take, there is one integrations from 0 to minus 2. Okay, and let's write this whole integrations as a minus 2 to 2 a minus out because we reverse the integration sign, and the odd term at one place and even term at another place. And as you can see, the denominator x square plus 2 is what? It's a even. So this is our whole objective. We will split whole function into the whole polynomial. You can say in denominator there is one polynomial. We will divide in sum of odd and even. So let's separate odd term here. As you know, x to the power 999 is a odd function. So we can collect here, and similarly 9 into x to the power 999 this is again odd. Third, 7 into x to the power 995, this is again odd function, plus x, this is a completely odd function. And let's write a even function. What is the even function? You can observe x to the power 4 is a even function, and minus 4 as it is, leave it, divide by, this is a even function, x square plus 2. Okay, the limit of integration minus 2 to 2x, and here write a dx. Just observe this part, and we can split this part and this part with this integrations separately. So as you know, if the function fx is an odd function, then the limit of integration minus a to a is 0. We just learned before a minute. Okay, so the whole term will cancel out and become 0. We will get only x to the power 4 minus 4 divided by x to the power 2 plus x to the power 2 plus 2 dx, from minus 2 to 2 minus. Okay, now apply algebraic property. We will split out x square minus 2 x square plus 2 divided by x square plus 2 dx minus 2 plus 2, limit of integration minus 2. This will be cancel out, minus term, and just after apply the power rule of integration, x to the power 3 by 3 minus 2x, and same time you can apply even property, because this function is an even function. You can apply the concept of even function or even property. Then it will be 2 times of 0 to 2. So whole integration will convert into 8 divided by 3 minus 4, 2 times 8 minus 12 divided by 3. Okay, so 2 times minus 4 divided by 3, it will be minus 8 by 3. Our answer will be minus 8 by 3. I hope you enjoyed the sessions and we learned odd even integration property, about statement of the property. We prove this property and we apply to solve one concept, one difficult problem. So that's all in this sessions. Thanks for watching, and I hope we will meet another sessions of a definite integration property.